Hey guys, this is just a guide of how to go through that non-Mendelian practice sheet. And we're going to start with incomplete dominance, which if you remember from our lesson on incomplete dominance, it's basically Mendel's law of dominance doesn't apply because it's saying that, sure, we've got two traits for two alleles, but whatever the outcome is or the phenotype is going to be a mixture of those two. So some examples of that are going to be what's on this paper here. We're taking maybe a red flower and a white flower and mixing it together, and the outcome is going to be pink. If Mendel's law is applied, pink shouldn't be an option, but in this case it's a rule breaker, so it does apply. That's why it's called non-Mendelian. So right here, for example, it's saying that we have a red snapdragon, and if this is a case of incomplete dominance, what would be the genotype? If we're using the letter R's, it should be big R, because the recessive trait or that white trait doesn't belong there. But we have a pink, and if you think about how in art class do you make pink if you just have red? You can't. You have to have red and white. So both the red and white allele should be there. So we'll represent that by writing a dominant and a recessive. But here we've got the white, which is just recessive. So two little r's will go ahead and be there. We're going to take two pink flowers and cross them in this scenario, and it's going to look a little bit like this. If I'm still going to go ahead and use that letter R, I'll have a big R, little r, and we'll go ahead and cross them in this Punnett square. So what I'm going to end up with is this flower right here is going to be red. These two flowers right here are going to be pink, and this one is going to be white. So for every one red, I have two pinks and one white. So I'm going to say for my genotype ratio that I have a 1 to 2 to 1 ratio. Cool thing about those non-Mendelians is that it's also going to be the phenotype. I have a 1 to 2 to 1 ratio for my phenotype. And then I've got the red here. Red going ahead and crossing with white. If I was a florist and I took a red flower and I crossed it with a white flower, what could I expect? And that is that 100% of your offspring are going to be pink. So it's 100% of the heterozygous trait, and 100% of those are pink. And one thing you might remember from class is that the only way for Mendel's laws to be broken here is for it to be heterozygous, because you have to have both traits in order for those traits to mix. Here we've got a pink and a white. So big R, little r for one parent, and little r for another, which is going to end up looking like this. These two are pink, and these two are white. So we have a 50-50, which you can write as a 1 to 1. And that's going to be the exact same for your phenotype percentage. All right, let's skip over to the next page. You can continue to practice this on this page by yourself, but the next page will help us a little bit. So in this scenario, we have a circle-eyed smiley face, a star-eyed smiley face, and then this circle star-eyed smiley face. And so we're going to go ahead and use two different letters here. And it doesn't matter what letters you choose as long as you get the right ratios. So here we're going to say that this is CC, this is SS, and in this case, circles with stars is going to be CS. If we're to show a cross between a star-eyed and a circle-eyed, it would look a little bit like this. If that's my Punnett square and I've got a star-eyed and a circle-eyed, every single one of my offspring should be circle star-eyed. So I'm going to go ahead and write that the phenotypes are the circle star eyes, and the genotype is that it's 100% circle stars. Pretty unique situation there. Alright, so we're going to go ahead and finish this section on incomplete dominance. Make sure you understand how to do it. If you have any questions, you can come talk to me.